August 12, 1943. Rechlin airfield, approximately 100 kilometers northwest of Berlin. The morning sun cast long shadows across the tarmac as Hauptmann Werner Voelter walked toward an aircraft that should not have been there. The distinctive twin-boom configuration was unmistakable. A Lockheed P-38 Lightning, painted in Luftwaffe testing colors, sat incongruously among German fighters. Yellow identification bands encircled the fuselage and tail surfaces. The Reich eagle and swastika marked where American stars had once been painted. Voelter had flown nearly every Allied fighter type recovered intact from crash sites across occupied Europe. He had tested captured Spitfires, evaluated salvaged Thunderbolts, and written detailed reports on the handling characteristics of British Hurricanes. But this machine represented something fundamentally different from anything he had previously encountered. The P-38 was not merely another single-engine fighter with slightly different performance characteristics. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This was America's only operational twin-engine single-seat fighter, and German intelligence reports suggested it possessed speed capabilities that seemed to defy conventional understanding of what twin engines should weigh and how fast they could propel a fighter-sized airframe. What Voelter would discover during the next 2 hours would fundamentally challenge his assumptions about American engineering philosophy and industrial capability. The experience would force him to confront an uncomfortable reality that many German pilots were beginning to recognize by mid-1943. The technical gap between American and German aviation was not closing. It was widening with each passing month. The story of how a captured P-38 Lightning became an instrument of revelation for experienced Luftwaffe test pilots begins not with this specific aircraft's forced landing in occupied territory, but with the broader evolution of American fighter design philosophy and the specific strategic requirements that gave birth to Lockheed's radical twin-engine concept. In 1937, the United States Army Air Corps issued a specification for a high-altitude interceptor capable of speeds exceeding 400 miles per hour with exceptional climb rate and heavy armament. The requirements seemed almost fantastical given contemporary fighter performance. Most fighters of the mid-1930s struggled to exceed 300 miles per hour. The Air Corps wanted something that could reach 40,000 feet altitude while maintaining combat effectiveness. Lockheed's design team, led by Hall Hibbard and Kelly Johnson, approached the problem with unconventional thinking. They recognized that no single available engine could deliver the required power within acceptable weight limits. Instead of waiting for more powerful engines or compromising performance, they chose twin engines. The decision carried significant risks and challenged conventional fighter design wisdom. Twin engines meant additional weight, more complex systems, greater drag, and increased maintenance requirements. Fighter doctrine emphasized agility and simplicity. Every pound of unnecessary weight degraded maneuverability. Every additional system created another potential point of failure. Most military planners considered twin-engine fighters unsuitable for air-to-air combat, relegating such designs to bomber-destroyer roles where speed and firepower mattered more than turning performance. But Lockheed engineers understood something that would only become apparent through extensive flight testing. If they could solve the aerodynamic challenges and integrate the twin-engine layout efficiently, they could create a fighter with performance that exceeded single-engine contemporaries, while providing redundancy that single-engine fighters could never match. The resulting aircraft, designated XP-38, first flew on January 27, 1939 at March Field, California. Even in prototype form, the aircraft demonstrated extraordinary performance. On February 11, 1939, Lieutenant Colonel Ben Kelsey flew the XP-38 from California to New York in 7 hours and 2 minutes, achieving an average speed of over 360 miles per hour. The transcontinental speed record demonstrated the aircraft's potential, even though the prototype crashed during the attempt to land at Mitchell Field due to carburetor icing. Development continued throughout 1939 and 1940 with Lockheed, refining the design, solving technical problems, and working to transform an experimental prototype into a production fighter. The challenges were substantial. The turbo-supercharged Allison V17-10 engines required complex ducting systems. The counter-rotating propellers demanded sophisticated mechanical systems to prevent torque issues. The tricycle landing gear was revolutionary but unproven. The concentrated nose armament required redesigning traditional fighter gunnery approaches. Production P-38 seconds began entering service with the Army Air Force in mid-1941. Early operational experience revealed both the aircraft's extraordinary potential and its significant teething problems. The engines proved temperamental in certain conditions. The turbo-superchargers required careful management. Cold weather operations exposed oil cooling problems that caused engine failures. Compressibility effects at high speed created control difficulties that killed test pilots before solutions were found and implemented. By 1942, as America fully entered World War II following Pearl Harbor, the P-38 had become operationally deployed with units in multiple theaters. In the Pacific, the Lightning's long range made it invaluable for operations across vast ocean distances. In North Africa, the aircraft supported Operation Torch and subsequent campaigns. In Europe, P-38 seconds began escorting bombers and conducting fighter sweeps, engaging Luftwaffe fighters under conditions that would test every aspect of the aircraft's design and every assumption about what twin-engine fighters could accomplish in air combat. German pilots first encountered P-38 seconds during the North African campaign in late 1942. Initial combat reports reflected confusion and surprise. German fighter pilots, accustomed to engaging single-engine adversaries, found themselves facing an aircraft that seemed to violate established performance parameters. The Lightning accelerated faster than expected for its size. It climbed more rapidly than twin engines should permit. And most disturbingly, it could achieve and sustain speeds that approached or exceeded those of Germany's best single-engine fighters at certain altitudes. Luftwaffe intelligence officers collected fragmentary combat reports, attempting to construct accurate performance profiles from chaotic accounts provided by pilots who had engaged P-38 seconds under combat stress. The reports were contradictory and incomplete. Some pilots claimed the Lightning was slow and unmaneuverable. Others insisted it possessed shocking acceleration and climb capability. The contradictions reflected the P-38's unusual performance envelope, which varied dramatically depending on altitude, power settings, and pilot skill. By early 1943, the Luftwaffe had recovered several crashed P-38 seconds from combat zones in North Africa and Europe. Most were too damaged for restoration to flight status, but one aircraft, serial number 42-10493, a P-38G model, came down relatively intact after its pilot executed a forced landing following mechanical failure during a sweep over Tunisia on March 4, 1943. Lieutenant Robert Morrison of the 14th Fighter Group had been flying number 2 position in a 4-ship flight, conducting armed reconnaissance south of Sfax when his left engine suffered catastrophic coolant system failure. The temperature gauges climbed rapidly into the red zone. Morrison shut down the affected engine and turned toward friendly territory, but the remaining engine could not maintain altitude while carrying full internal fuel and external drop tanks. Morrison faced the difficult choice between ditching in the Mediterranean or attempting to reach territory that might offer hope of rescue. He chose the latter, nursing the Lightning as far inland as possible before the inevitable forced landing in an agricultural area controlled by German ground forces. The aircraft struck hard but remained largely intact. Morrison survived without serious injury and would spend the remainder of the war as a prisoner. His fighter, abandoned in that Tunisian field, would soon become one of the Luftwaffe's most valuable intelligence assets of 1943. German salvage teams reached the site within hours. They assessed the damage carefully and determined the aircraft could be repaired given sufficient resources and appropriate technical expertise. The P-38 was carefully dismantled, loaded onto transport, and shipped to Germany through an increasingly complicated and dangerous supply chain that crossed the Mediterranean under constant threat of Allied air attack. The aircraft arrived at Rechlin in July 1943. Luftwaffe technicians and engineers examined every system with meticulous attention. They measured dimensions, photographed components, analyzed materials, and documented construction techniques. They studied the turbo-supercharger installations, the intercooler systems, the counter-rotating propeller mechanisms, and the concentrated nose armament arrangement. The restoration required several weeks. Components had to be fabricated or cannibalized from other wrecks. The left engine needed complete replacement using parts from a P-38 that had crashed in France. Fuel and hydraulic systems required repair. The electrical system needed troubleshooting and restoration. Throughout the process, German engineers gained intimate familiarity with American manufacturing techniques, quality control standards, and design philosophies that differed markedly from German approaches. By early August, the Lightning was ready for flight testing. The aircraft had been repainted in Luftwaffe colors with yellow identification markings. German test pilots would soon discover what American pilots had learned through thousands of operational hours in multiple theaters. The P-38 Lightning represented a fundamental breakthrough in fighter performance, achieving capabilities that seemed impossible given the aircraft's size, weight, and twin-engine configuration. Werner Voelter climbed into the cockpit that August morning with professional curiosity tempered by caution. Test flying enemy aircraft carried inherent risks beyond normal flight operations. Systems might fail unexpectedly. Repair quality might prove inadequate under stress. Unknown quirks could surprise pilots, unfamiliar with specific handling characteristics. German test pilots had died flying captured Allied types when unexpected problems emerged during flight testing. The cockpit layout struck Voelter immediately as distinctly American in its design philosophy. Controls were arranged logically with clear labeling. Switches were substantial and positive in their action. The instrument panel appeared less densely packed than German fighters, with larger gauges and clearer organization. The seats provided better padding and adjustability than Messerschmitt or Focke-Wulf designs. The overall impression suggested American designers prioritized pilot comfort and ease of operation in ways that German engineers tended to subordinate to other considerations. Voelter worked through the starting procedure using captured technical manuals translated by Luftwaffe intelligence specialists. The Allison engines caught and settled into, smooth running with reassuring mechanical confidence. Engine instrumentation showed normal temperatures and pressures. The auxiliary systems functioned as expected. Voelter taxied carefully, feeling for any tendency toward ground looping or directional instability. The tricycle landing gear provided exceptional forward visibility compared to tailwheel fighters. The nosewheel steering proved smooth and responsive. After completing pre-flight checks, Voelter advanced the throttles for takeoff. The acceleration was immediate and powerful. Despite weighing over 15,000 pounds at combat weight, the Lightning leaped forward with shocking thrust. The tricycle gear kept the aircraft level throughout the takeoff run, eliminating the delicate balancing act required by tailwheel designs. The aircraft lifted smoothly at approximately 110 miles per hour indicated airspeed. Voelter raised the landing gear and felt the aircraft accelerate as drag reduced dramatically. The initial climb away from Rechlin revealed the P-38's first distinctive characteristic. At full military power, the Lightning climbed at better than 3,000 feet per minute from sea level. For a twin-engine fighter weighing nearly 8 tons, this performance seemed extraordinary. German twin-engine fighters like the Messerschmitt 110 achieved respectable performance, but nothing like the combination of speed and climb rate the P-38 demonstrated. Voelter leveled at 10,000 feet and began systematic performance testing. He accelerated straight and level, noting the airspeed indicator climbing steadily past 300 miles per hour, then 350, then approaching 400. At full military power at 10,000 feet, the Lightning achieved approximately 390 miles per hour true airspeed. This matched or exceeded the maximum speed of the Messerschmitt 109G at the same altitude. Despite the P-38's significantly greater weight, twice as many engines, the airframe felt solid at high speed. There was none of the buffeting or roughness that afflicted some fighters near their maximum velocity. The controls remained responsive and precise. Voelter executed a series of turns, climbs, and dives to explore the handling characteristics throughout the performance envelope. The Lightning maneuvered surprisingly well for its size. It would not outturn a Messerschmitt 109 in sustained turning combat. But at high speed, the effective controls and powerful engines allowed maneuvers that many single-engine fighters could not match. The P-38's most remarkable characteristic became apparent during high-speed acceleration tests. Voelter pushed the throttles forward from cruise power to maximum continuous power while holding level flight at 15,000 feet. The Lightning accelerated with shocking rapidity. The airspeed indicator climbed faster than any single-engine fighter Voelter had flown. Within seconds, the aircraft had added 60 miles per hour. The acceleration continued smoothly past 400 miles per hour indicated. This performance characteristic had profound tactical implications that Voelter immediately recognized. In combat, the ability to accelerate rapidly meant the P-38 pilot could choose whether to engage or disengage from nearly any situation. If bounced by enemy fighters, the Lightning pilot could push throttles forward and simply accelerate away from most pursuers. If pursuing an enemy, the rapid acceleration allowed the P-38 to close distance quickly before the target could escape. The combination of high maximum speed and exceptional acceleration created a tactical flexibility that few fighters possessed. Voelter climbed to 25,000 feet to test high-altitude performance. This regime represented the P-38's design strength. The turbo-supercharged engines maintained their power output at altitudes where normally aspirated engines lost significant performance. At 25,000 feet, the Lightning still achieved speeds exceeding 370 miles per hour. The climb rate remained over 2,000 feet per minute. These performance figures exceeded anything German fighters could achieve at equivalent altitudes in mid-1943. The Messerschmitt 109G suffered significant power loss above 20,000 feet. The Focke-Wulf 190A used a mechanically supercharged engine that performed well at medium altitudes, but lost effectiveness above 22,000 feet. Both German fighters struggled to maintain combat effectiveness at altitudes where the P-38 operated with authority and confidence. After 90 minutes of systematic testing, Voelter returned to Rechlin with a comprehensive understanding of the Lightning's capabilities and limitations. He landed smoothly, using the excellent forward visibility and stable handling to execute a precise approach and touchdown. As he shut down the engines and completed post-flight procedures, Voelter began mentally drafting the technical report that would circulate through Luftwaffe Fighter Command within days. The report Voelter and other test pilots eventually produced documented the P-38's performance in comprehensive detail. Maximum speeds at various altitudes, climb rates throughout the altitude envelope, service ceiling exceeding 40,000 feet, combat radius approaching 500 miles with external fuel tanks, armament consisting of one 20mm cannon and 450 caliber machine guns, all mounted in the nose with no synchronization required, providing devastating firepower with excellent ballistic concentration. The report noted specific strengths that gave P-38 pilots significant tactical advantages. The high-altitude performance enabled the Lightning to escort bombers at altitudes where German fighters struggled. The long range allowed missions deep into German-controlled territory that single-engine fighters could not reach. The exceptional acceleration and high-speed performance provided tactical flexibility in engagement and disengagement. The redundant engines offered safety over water and hostile territory that single-engine designs could never match. The technical analysis also documented weaknesses German pilots could potentially exploit. The P-38's rate of roll at high speeds was inferior to single-engine fighters due to the heavy wing structure required to mount engines and landing gear. The aircraft's turn radius at low to medium speeds exceeded that of lighter single-engine opponents. The complex turbo-supercharger systems proved vulnerable to combat damage. The engines suffered reliability problems in extreme cold conditions. The compressibility effects at very high speeds created control difficulties that could be dangerous if not properly managed. But the weaknesses, while real and potentially exploitable, could not overcome the fundamental performance advantages the Lightning possessed. Luftwaffe fighter pilots reading the technical reports understood immediately that the P-38 represented a serious threat that would require changes in German tactical doctrine and potentially force development of new German fighters with improved high-altitude performance. The captured P-38 remained at Rechlin throughout late 1943 and into 1944. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this, used for ongoing testing and training purposes. The aircraft participated in the Wunderzirkus Rosarius program, the traveling circus of captured Allied aircraft that visited operational Luftwaffe fighter bases across Germany and occupied territories. Frontline German pilots examined the Lightning up close, sat in the cockpit, and in some carefully selected cases, flew brief familiarization flights to gain direct personal experience with Allied equipment. The demonstrations served multiple purposes. They provided tactical intelligence to operational pilots who might face P-38 seconds in combat. They dispelled myths and rumors about Allied aircraft capabilities by providing direct observation rather than second-hand reports. They boosted morale by showing that Allied aircraft could be captured and studied rather than appearing invincible. And perhaps most importantly, they forced German pilots and commanders to confront uncomfortable realities about Allied industrial capabilities and technical sophistication. German pilots who flew the captured P-38 repeatedly commented on specific characteristics that distinguished it from German fighters. The smoothness of the engines impressed everyone who experienced them. The harmonious integration of systems suggested design maturity rarely seen in German prototypes. The quality of materials and manufacturing precision indicated industrial capabilities that Germany was increasingly unable to match, as Allied bombing disrupted production and raw material shortages intensified. One Luftwaffe pilot, Oberleutnant Franz Stigler, who flew the captured P-38 during a Wunderzirkus demonstration in early 1944, later recalled his surprise at the aircraft's refinement. In post-war interviews, Stigler described the Lightning as feeling more like a transport aircraft than a fighter in terms of stability and smoothness, but with performance that exceeded anything Germany had in operational service at comparable altitudes. The combination seemed almost contradictory, sophisticated civilian comfort married to aggressive military performance. The captured P-38 testing program provided valuable tactical intelligence, but the knowledge gained could not overcome fundamental strategic imbalances. By mid-1944, Germany faced overwhelming Allied material superiority in every dimension of aerial warfare. American and British factories produced aircraft in quantities that dwarfed German output, despite round-the-clock Allied bombing of German industrial centers. The United States alone manufactured over 96,000 fighters during World War II. Germany produced approximately 40,000 fighters total. The numerical disparity meant that even superior German pilot skill and tactical doctrine could not prevent Allied air superiority from becoming absolute by late 1944. Every German fighter shot down was increasingly difficult to replace. Every experienced pilot killed represented a loss that accelerated the decline in overall Luftwaffe effectiveness. The P-38 production numbers illustrated American industrial capacity. Lockheed manufactured over 10,000 Lightnings between 1941 and 1945. This represented just one of several American fighter types in mass production. The Republic P-47 Thunderbolt exceeded 15,000 units. The North American P-51 Mustang reached nearly 16,000 units, and these were merely single-seat fighters. Medium and heavy bomber production, transport aircraft, trainers, and other types added tens of thousands more aircraft to American strength. German factories struggled to produce sufficient aircraft even before Allied bombing intensified. Raw material shortages limited aluminum availability. Chronic fuel shortages restricted flight training for new pilots. Experienced maintainers were conscripted for ground combat as manpower shortages intensified. The entire German war economy strained under pressures that mounted with each passing month. By 1944, Germany fought not merely against Allied tactical and technical superiority, but against industrial and material advantages so overwhelming that ultimate defeat became mathematically inevitable, regardless of individual courage or tactical skill. The Luftwaffe attempted to counter Allied advantages through advanced technology. The Messerschmitt 262 jet fighter represented the most successful German effort to leapfrog Allied piston engine fighters through revolutionary propulsion technology. The Tu-62 possessed substantial speed advantages, reaching speeds exceeding 540 miles per hour, making it the fastest operational fighter of World War II. But the Tu-62 arrived too late and in insufficient numbers to alter strategic outcomes. The aircraft entered service in summer 1944 when Allied air superiority was already absolute. Production difficulties, engine reliability problems, fuel shortages, and pilot training limitations prevented the Tu-62 from deploying in numbers necessary to seriously threaten Allied operations. By war's end, approximately 1,400 Tu-62s had been produced, but fewer than 300 saw sustained operational service. The jet fighter's impressive technological achievements could not overcome the fundamental reality that Germany lacked the resources, industrial capacity, and strategic position necessary to reverse the air war's outcome. Every Tu-62 produced required resources that might have built 3 or 4 conventional fighters. Every hour of jet fuel consumed represented gasoline that could not go to training units or transport aircraft. The Tu-62 represented Germany's remarkable engineering capabilities, but also demonstrated how technological sophistication alone cannot substitute for industrial capacity and strategic advantage. Throughout 1944, as the Allies advanced from multiple directions and German defences crumbled under irresistible pressure, the captured P-38 at Rechlin continued serving as a teaching tool and intelligence asset. New Luftwaffe pilots received briefings about American fighter capabilities. Tactical doctrine updates incorporated lessons learned from captured aircraft analysis. Training programs emphasized techniques for countering specific Allied advantages, but the knowledge gained from flying captured enemy aircraft could not change the fundamental strategic situation. Germany faced opponents with superior numbers, better equipped forces, more thoroughly trained personnel, virtually unlimited industrial capacity, and secure rear areas beyond the reach of German attack. The material balance favored the Allies so overwhelmingly by late 1944 that tactical innovations and individual heroism could delay but not prevent Germany's inevitable and total defeat. The captured P-38 flew its last test mission sometime in early 1945 as Allied armies approached from east and west, squeezing Germany into an ever-shrinking defensive perimeter. The aircraft's ultimate fate remains uncertain. It may have been destroyed during an Allied bombing raid on Rechlin. It might have been captured intact by advancing Soviet forces, or perhaps Luftwaffe personnel destroyed it to prevent capture. Records from that chaotic period are incomplete and contradictory. What remains certain is the impact that flying the captured Lightning had on experienced German test pilots like Werner Voelter. They confronted undeniable evidence that American aviation industry had achieved technical capabilities and manufacturing sophistication that matched or exceeded Germany's despite American industry transforming from peacetime production to war footing in less than 2 years. The admission by German test pilots that they had never encountered 400-mile-per-hour performance from a twin-engine fighter represented professional acknowledgement of American engineering achievement. It illustrated how direct personal experience with enemy equipment could shatter assumptions and force realistic assessment of opponent capabilities, even when such assessments contradicted propaganda narratives about Allied industrial inferiority. German test pilots examining the P-38's construction noted details that revealed American manufacturing philosophy. The extensive use of flush riveting reduced drag and demonstrated manufacturing precision. The sophisticated electrical systems showed advanced understanding of complex integration. The attention to pilot ergonomics suggested design priorities that placed operational effectiveness above theoretical performance optimization. These details, individually small, collectively revealed an industrial culture that combined practical engineering with sophisticated technical mastery. The psychological impact of flying advanced enemy equipment extended beyond tactical intelligence to strategic understanding. German pilots who experienced the P-38's performance firsthand understood viscerally that Germany faced opponents with not merely numerical superiority, but also technical capabilities equal to or exceeding German achievements. This realization, particularly when combined with evidence of overwhelming Allied material production, forced recognition that victory was no longer achievable, regardless of will or sacrifice. Professional military officers grounded in reality could not ignore evidence directly experienced. Flying the captured P-38 provided undeniable proof that Allied aircraft designers understood aerodynamics, propulsion systems, and fighter requirements as thoroughly as their German counterparts. The implication was inescapable. If America could design and mass-produce fighters this capable while simultaneously fielding thousands of bombers, hundreds of thousands of trucks, vast quantities of ammunition, and all the other materiel modern warfare consumed in staggering quantities, then Germany could not win through military means alone. The story of the captured P-38 Lightning illustrates how technical intelligence programs attempt to understand opponent capabilities through systematic analysis and direct testing. The Luftwaffe's captured aircraft program provided valuable tactical information that helped German pilots survive longer and fight more effectively. But tactical intelligence alone cannot overcome strategic disadvantages, rooted in industrial capacity, resource availability, and geographic position. Werner Voelter survived the war and continued his aviation career in post-war Germany. In interviews conducted decades later, he spoke candidly about his experiences flying captured Allied aircraft. He described the P-38 as one of the most impressive fighters he tested, particularly praising its high-altitude performance and remarkable acceleration. He noted that by 1943, experienced German pilots understood they faced increasingly sophisticated opponents with advantages that extended beyond mere numbers to include technical capabilities that matched or exceeded German achievements. The legacy of captured aircraft testing programs extends to modern military intelligence operations. Every major power maintains units dedicated to obtaining and evaluating opponent equipment. The insights gained inform tactical doctrine, weapon development, and strategic planning. But the fundamental lesson from World War II remains valid. Technical intelligence provides understanding, but cannot substitute for industrial capacity, trained personnel, adequate resources, and sound strategy. The P-38 Lightning served throughout World War II in every theater where American forces operated. In the Pacific, the aircraft's long range made it invaluable for operations across vast ocean distances. In Europe, Lightnings escorted bombers, flew reconnaissance missions, and engaged Luftwaffe fighters. In the Mediterranean, P-38 seconds supported ground operations and maintained air superiority over invasion beaches. The aircraft's versatility and performance validated Lockheed's unconventional design decisions and demonstrated that twin-engine fighters could succeed in roles previously reserved for single-engine types. By war's end, P-38 seconds had achieved over 3,700 aerial victories in the Pacific theater alone. America's top ace, Major Richard Bong, with 40 victories, flew P-38 seconds exclusively. The second-ranking ace, Major Thomas Maguire, with 38 victories, also flew Lightnings. The aircraft's combination of speed, range, firepower, and reliability made it one of the most successful American fighters of the war, despite early developmental challenges and ongoing maintenance complexities. The admission by Luftwaffe test pilots that the P-38's 400-mile-per-hour twin-engine performance exceeded anything they had previously encountered represents one small moment in a vast global conflict. But that moment of recognition, repeated countless times as German personnel confronted evidence of Allied industrial and technical capabilities, contributed to the psychological erosion that accompanied Germany's military defeat. Professional soldiers could see with their own eyes and experience with their own hands the quality and quantity of equipment their opponents fielded. Such evidence could not be dismissed through propaganda or wishful thinking. The captured P-38 at Rechlin stands as a symbol of this broader pattern. German test pilots flew an aircraft that should not have been able to achieve the performance it demonstrated. Their written reports documented capabilities that challenged assumptions about what twin engines could accomplish in a fighter airframe. Those reports circulated through Luftwaffe commands, informing tactical decisions and strategic planning. But the knowledge gained could not alter the fundamental reality that Germany faced opponents with decisive advantages in every category that mattered for sustained modern warfare. The story concludes not with dramatic aerial combat or heroic sacrifice, but with professional military personnel conducting technical analysis and reaching conclusions based on evidence rather than ideology. Werner Voelter's test flights in August 1943 provided valuable intelligence, but they also provided undeniable proof that American aviation had achieved extraordinary capabilities through unconventional design solutions executed with manufacturing, precision and engineering sophistication. That realization, multiplied across thousands of German personnel who examined captured Allied equipment, helped create the psychological foundation for understanding that military victory was no longer achievable. The war would continue for nearly 2 more years after Voelter's flights. Millions more would die, cities would burn, armies would clash in desperate battles. But the outcome was already determined by industrial capacity, material resources, and technical capabilities that increasingly favored the Allies. The captured P-38 Lightning, that one aircraft pulled from a Tunisian field and restored to flight at Rechlin, served as a messenger bringing uncomfortable truths to German pilots who possessed the professional competence to understand what those truths meant. The admission that they had never seen 400-mile-per-hour performance from a twin-engine fighter was simultaneously a technical observation and an acknowledgement of Allied achievement. Both as an observation and an acknowledgement, it represented reality confronting assumptions, evidence displacing ideology, and professional competence recognizing capabilities that propaganda insisted did not exist. That is perhaps the most instructive legacy of the captured P-38 program. Not the tactical intelligence gathered or the training benefits provided, but the demonstration that direct experience with enemy equipment forces realistic assessment, regardless of political narratives or ideological commitments. Professional military personnel examining Allied aircraft with technical competence could not deny what they measured, observed, and personally experienced. The Lightning's performance spoke for itself in ways no propaganda could contradict or minimize. The German pilots who flew captured P-38 seconds carried that knowledge with them through the war's final years. They understood what they faced, not through abstract intelligence reports, but through personal experience in the cockpit. That understanding could not change the war's outcome, but it did provide clarity about why the outcome had become inevitable. American industry had not merely produced more aircraft, it had designed and manufactured fighters whose capabilities matched Germany's best achievements while exceeding them in critical categories like range, high-altitude performance, and sustained speed. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.